This slide introduces Section 2, which focuses on value stream mapping, or VSM, in the supply chain. VSM is a lean tool used to visualize the complete flow of materials and information from suppliers to customers. It helps identify waste, delays, and inefficiencies in the process. In this section, we will learn how to map current processes, analyze gaps, and design improved future state supply chains for better efficiency, faster delivery, and enhanced customer value. This slide explains the concept and purpose of value stream mapping, or VSM. VSM is a lean tool used to visualize the complete flow of materials and information from supplier to customer. It helps identify bottlenecks, waste, and inefficiencies in the process. The purpose of VSM is to highlight non-value-added activities, measure lead and waiting times, improve coordination between teams and partners, and create a clear roadmap for continuous improvement and better supply chain performance. This slide shows a practical example of value stream mapping in action. A consumer goods company mapped its order-to-cash process and discovered that 30% of the total lead time was wasted in approvals and unnecessary handling. By eliminating these non-value-added activities and streamlining the process, the company improved delivery time by 22%. This demonstrates how VSM helps identify inefficiencies and improve overall supply chain performance. This slide explains why value stream mapping is important in the supply chain. VSM helps build a common understanding among different functions like procurement, production, and logistics. It provides a clear baseline to support lean transformation. VSM also enables fact-based decision-making by showing actual process data instead of assumptions. Finally, it helps design an improved future state process, leading to better efficiency, reduced waste, and improved overall supply chain performance. This slide explains value-added and non-value-added activities from the customer's perspective. Value-added activities directly transform the product or service and are something the customer is willing to pay for, such as assembly or packaging. Non-value-added but necessary activities support business operations, like inspection or documentation. Pure waste activities add no value, such as waiting, rework, or unnecessary transport. The goal of lean is to eliminate waste and minimize non-value-added activities to improve efficiency and customer value. This slide explains techniques used to identify waste in supply chain processes. Gemba walks involve observing actual processes at the workplace. Time studies help measure cycle time and waiting time to detect inefficiencies. Process mapping workshops bring teams together to analyze workflows. Voice of the customer helps understand what customers truly value. For example, a pharma distributor identified waste in redundant documentation and, by introducing digital forms, saved 15 hours per week, improving efficiency. This slide explains the 5 key steps to create a value stream map. First, select the value stream by choosing the product or process to analyze. Second, map the current state to understand the existing flow and timings. Third, identify waste by finding bottlenecks and inefficiencies. Fourth, design the future state with an improved process flow. Finally, develop an action plan by assigning responsibilities and timelines. These steps help organizations move from the current state to a more efficient future state. This slide explains the key data required to create an accurate value stream map. Important data includes process lead time, cycle time, setup time, inventory levels, and information flow. This data helps identify delays, bottlenecks, and inefficiencies. For example, a packaging plant found that only 20% of total lead time was actual processing, while 80% was waste due to waiting and delays. This highlights the importance of data in identifying improvement opportunities. This slide explains the common symbols used in value stream mapping. A process box represents an activity step, while a data box shows important metrics like cycle time and defect rate. Arrows indicate material and information flow. A lightning bolt highlights bottlenecks or problems, and an inventory triangle shows waiting materials. These symbols help visualize the entire process clearly, making it easier to identify waste and improvement opportunities. This slide explains the key metrics used in value stream mapping for supply chains. Lead time measures the total time from order to delivery, while cycle time measures actual processing time. Process efficiency shows how much time is value added versus wasted. Inventory days indicate how long stock stays in the system, and information accuracy ensures smooth coordination. For example, a logistics company improved process efficiency from 18% to 41% by automating data exchange, reducing delays, and improving flow. This slide explains how to visualize metrics in a value stream map. Key performance data is placed below each process box to show cycle time, lead time, and efficiency. Color coding is used to identify activity types: green for value added, yellow for necessary but non-value added, and red for pure waste. This visual approach helps teams quickly identify improvement areas and focus on eliminating waste to improve overall supply chain performance. This slide explains the flow efficiency formula, which measures how much of the total lead time is actually spent on value-added activities. It is calculated as value-added time divided by total lead time, multiplied by 100. This metric helps identify the level of waste in the process. A flow efficiency above 30% is considered good, while below 10% indicates high waste and significant improvement opportunities. This slide presents a case study of value stream mapping in an FMCG company's procurement process. Initially, the process had 9 approval levels, multiple manual forms, and a lead time of 12 days. By introducing e-approvals and simplifying the workflow, the company reduced the lead time to just 4 days. This improvement resulted in significant efficiency gains, and annual cost savings of 1.2 Indian rupees crore, demonstrating the powerful impact of VSM in optimizing supply chain processes. This slide presents a case study of distribution network optimization using value stream mapping. A beverage company found that 40% of truck time was wasted waiting for loading and unloading. By implementing cross-docking and better route planning, they reduced waiting time by 65%. As a result, the company achieved 22% higher throughput using the same fleet, improving efficiency without additional resources. This slide presents a case study of warehouse operations improvement using value stream mapping. The distributor identified redundant barcode scanning at both inbound and outbound stages, which caused delays. By implementing a single barcode scan at entry and integrating it with the ERP system, they streamlined the process. As a result, they saved 4 minutes per order and increased daily dispatch capacity by 20%, improving overall warehouse efficiency.